Hello everyone, this is Chinnaiah Kalpana here. In this video we are going to solve a differential equation. So let's get going. Problem solve 1 plus x power 4 d cube 2 times x plus 1 whole cube d square. It's x plus 1 whole power 4 d cube plus 2 times x plus 1 whole cube into d square minus x plus 1 whole square into d plus x plus 1 into y equal to 1 by x plus 1. Solution. We are given a differential equation x plus 1 power 4 d cube plus 2 times x plus 1 whole cube d square minus x plus 1 whole square into d plus x plus 1 into y equal to 1 by x plus 1, right? Consider it as equation number 1. If you notice, you are having x plus 1 power 4 d cube, x plus 1 whole cube d square, x plus 1 whole square into d power 1 into plus x plus 1, right? You are having power 4 when you are having d to the power 3, and here you are having cube when you are having 2 here, having 3, you are having 1 in the power of d. So what we'll do is we'll just take 1 x plus 1 common from all these 4 terms. Then you'll get x plus 1 into x plus 1 whole cube d cube plus 2 times x plus 1 whole square d square minus x plus 1 into d plus 1 into y equal to 1 by x plus 1, right? Now let's take this x plus 1 to RHS. Then you'll get x plus 1 whole cube d cube plus 2 times x plus 1 whole square d square minus x plus 1 into d plus 1 into y equal to 1 by x plus 1 into x plus 1, right? Which gives us x plus 1 whole cube d cube plus 2 times x plus 1 whole square d square minus x plus 1 into d plus 1 into y equal to 1 by x plus 1 whole square, right? So this is of the Legendre's equation form. We know that Legendre's equation ax plus b, Legendre's equation is of the form ax plus b power n into d power n plus p1 into ax plus b power n minus 1 d power n minus 1 plus so on plus pn into y equal to some function of x. See, our equation is of this form, right? So we have reduced the given differential equation to Legendre's equation form. Right. Now consider this equation as equation number 2, and we'll reduce this equation to a linear differential equation with constant coefficients by using some substitution. Okay, let's see that. From Legendre's equation procedure, we know that ax plus b equal to e power z, then z equal to log of ax plus b, and theta is the differential operator whose independent variable is z, and ax plus b into d can be replaced by, here you are having powers 1, that is ax plus b power 1 into d power 1, so you will have only one term of theta into coefficient of x a, which is a theta, right? And ax plus b whole square d square can be replaced by, here you are having squares, right? So you will get two terms of theta into coefficient of x square, that is a square. Okay. Likewise, when you have cube, ax plus b whole cube into d cube, you'll have three terms of theta into a cube, that is coefficient of x cube, right? In our case, and coming to this problem, x plus 1, let x plus 1 equal to e power z. Let x plus 1 equal to e power z. Then z equal to log of x plus 1. Here theta is a differential operator whose independent variable is z. And here we can replace x plus 1 into d by, here you are having powers 1, right? So you will have only one term of theta into coefficient of x 1. 1 into theta is theta. And x plus 1 whole square into d square. X plus 1 whole square into d square can be replaced by, here you are having squares, right? Part 2. So you'll have only two terms of theta into 1 square. This gives us theta of theta minus 1. Likewise, x plus 1 whole cube into d cube can be replaced by, here you're having cube. So you'll have three terms of theta. Theta into theta minus 1 into theta minus 2. Quotient of quotient of x, which is 1 cube, which gives us theta into theta minus 1 into theta minus 2. Okay, now this equation becomes, it is equation 2 becomes replace x plus 1 whole cube into d cube by theta of theta minus 1 into theta minus 2 plus 2 times replace x plus 1 whole square into d square by theta of theta minus 1 minus replace x plus 1 into d by theta plus 1 into y equal to 1 by replace x plus 1 by e power z, or you can write 1 by x plus 1 whole square as x plus 1 power minus 2, or just replace x plus 1 by e power z. You will get 1 by e power z whole square, right? See, after writing this equation, you can write one more equation by just replacing 1 by x plus 1 whole square with x plus 1 power minus 2. Okay, or you can just go with the flow. Since 1 by x plus 2, sorry, it's 1, right? 1 whole square equal to x plus 1 power minus 2. If you will write 1 by x plus 1 whole square as x plus 1 power minus 2, then in the next step, while replacing x plus 1 by e power z, you will get e power z power minus 2. This is e power minus 2z. Okay, you will get the same thing. This gives us theta into theta minus 1 gives theta square minus theta, and theta into theta minus 1 into theta minus 2 will be equal to theta square minus theta into theta minus 2, which gives us theta square into theta, theta cube, minus theta square into 2 theta, sorry, it's 2 theta square, minus theta into theta is minus theta square, minus into minus plus theta into 2 theta, right? So you'll get theta square minus 3, it's cube, theta cube minus 3 theta square plus 2 theta, right? Let's replace this by theta cube minus 3 theta square plus 2 theta plus 2 times theta into theta minus 1 is theta square minus theta plus 1 into y equal to 1 by e power 2z. This gives us theta cube minus 3 theta square plus 2 theta plus 2 theta square minus 2 theta minus theta plus 1 into y equal to reciprocal of e power 2z is e power minus 2z. See, we got the same thing, e power minus 2z. Here plus 2 theta minus 2 theta gets cancelled and you'll get theta cube minus 3 theta square plus 2 theta square gives minus theta square minus theta plus 1 into y equal to e power minus 2z. Consider it as equation number 3, which is an operator form, say f of theta into y equal to some function of z. I'll write the function of z or the RHS part of the reduced equation as some r, where f of theta equal to theta cube minus theta square minus theta plus 1 and r equal to e power minus 2z. right? So here we have reduced the given differential equation to a differential equation with constant coefficients, right? So now we are going to find the solution to this equation. The general solution to the reduced equation, equation 3, is given by y equal to yc plus yp, where yc is a complementary function. We'll find this using auxiliary equation, and yp using f of 1 by f of theta into r. Okay, by finding the general solution to equation 3 using y equal to yc plus yp, we'll find the general solution to equation 1. Okay, the general solution to equation 3 results in terms of z, while coming to equation 1, the general solution results in terms of x. We'll see that. Okay, now coming to the auxiliary equation. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of theta, theta's cube minus theta square minus theta plus 1, right? Let's replace f of theta, theta in f of theta by m, so that you'll get f of m equal to m cube minus m square minus m plus 1. Then the auxiliary equation becomes m cube minus m square minus m plus 1 equal to 0. Now take m square common from the first two terms, you'll get m square times m minus 1, and take minus common from the next two terms, you'll get minus of m minus 1, right? So you can observe that m minus 2 exists in both the terms, so let's take it common. You'll get m minus 1 into m square minus 1 equal to 0. We can write this 1 as 1 square, which gives us m square minus 1 square equal to 0, which is of a square minus b square form. So we can write it as a plus b into a minus b, right? Then m minus 1 into m minus 1 into m plus 1 equal to 0. Now equate each factor to 0. When m minus 1 equal to 0, m equal to 1. When m plus 1 equal to 0, m equal to minus 1, right? Since m minus 1 is repeating twice, so you'll get m equal to 1, 1, and you have only one m plus 1, so you'll get m equal to minus 1. So you are having two equal root and one distinct root, which are real. Okay, so these are the roots to this auxiliary equation. Therefore, the two roots are real and equal, and one root is distinct, that is real and distinct. Right? These two are equal and this is distinct root. Okay, we have two equal roots and one distinct roots. All the roots are real. Okay, now coming to YC. We got real roots in which two are equal and one is distinct. Okay, we know that when two roots say m1 and m2 are real and distinct, then yc will be c1 plus c2z into e power that equal root into z, right? When you get some distinct roots, say m3, then yc will be another constant into e power, it's y, m3, okay? E power distinct root into z. Now coming to our yc. Yc equal to, first we'll write for the two equal roots, that is c1 plus c2z into e power equal root into z, plus now we'll write for the distinct root minus 1. One constant into e power distinct root into z. This gives us yc equal to c1 plus c2z into e power z plus c3 e power minus z. Therefore, yc equal to c1 plus c2z into e power z plus c3 e power minus z is a complementary function. Now we need to find yp. Yp is given by 1 by f of theta into r, where f of theta is theta cube minus theta square plus, it's minus theta plus 1 into r is e power minus 2z, right? So this is of 1 by f of theta into e power az type, right? We have f of theta equal to theta cube minus theta square minus theta plus 1. Now we need to find, just compare these two. By comparing these two, we'll get a equal to minus 2. So we'll find f of a, which is f of minus 2. Simply substitute theta equal to minus 2. Then you'll get minus 2 whole cube minus of minus 2 whole square minus of minus 2 plus 1, which gives us minus 2 whole cube is minus 8 minus minus 2 whole square is 4 minus into minus plus 2 plus 1, which gives us minus 8 minus 4 is minus 12 plus 3, which is minus 9. Non-zero, which is non-zero, right? See, by replacing theta by minus 2, we'll get the denominator minus 9, which is a non-zero number, right? Since f of minus 2 is not equal to 0, so we can replace we can replace theta by minus 2. Okay, if you get 0, if you get f of minus 2 is 0, then 1 by the denominator term becomes 0 into e power minus 2z. You'll get like this. If f of minus 2 is 0, you'll get 1 by 0 into e power minus 2z, which becomes undefined. Okay, but in our case, our f of minus 2 is non-zero, so we can just replace theta by minus 2. This becomes 1 by right, which gives us or we can write it as minus 1 by 9 e power minus 2z. Therefore, yp equal to minus 1 by 9 e power minus 2z. Now we are having yc and yp. Let's now find the general solution to equation 3. It's equation 3, right? Not 2, it's equation 3. Fine, let's now find the general solution to equation 3. Therefore, the general solution to equation 3 is given by y equal to yc plus yp. Then y equal to yc, we have c1 plus c2z into e power z plus c3 e power minus z plus yp minus 1 by 9 e power minus 2z, which is in terms of z. Okay, the general solution to equation 3 is in terms of z. Now using this solution, we'll find the general solution to the given equation. we have y equal to c1 plus c2z into e power z plus c3 e power minus z minus 1 by 9 e power minus 2z, right? Now we are going to replace e power z by x plus 1. So what I'll do is, I'll just write this e power minus z as e power z power minus 1 minus 1 by 9 into, you can write e power minus 2z as e power z power minus 2. Now it will be easy to replace e power z by x plus 1 and z by log of x plus 1, since x plus 1, since e power z is equal to x plus 1 and z equal to log of x plus 1. So now we'll replace x e power z by x plus 1 and z by log of x plus 1. Then this becomes y equal to c1 plus c2, replace z by log of x plus 1 into e power z, replace e power z by x plus 1 plus c3, replace e power z by x plus 1, you'll get x plus 1 power minus 1 minus 1 by 9 into, replace e power z by x plus 1, you'll get x plus 1 power minus 2. Therefore, y equal to c1 plus c2 log of x plus 1 into x plus 1 plus c3 x plus 1 power minus 1 minus 1 by 9 into x plus 1 power minus 2 is the required solution, which is the general solution to the given differential equation, which is in terms of x. Which is the required solution to a problem. So this completes the problem. Well, we have seen a problem from differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.